Welcome to today's episode, where we're diving into the intriguing world of distributed systems. We'll be focusing on gossip protocols and anti-entropy mechanisms, two concepts that are vital for ensuring reliable communication and data consistency across large-scale networks. Whether you're just starting out in tech or you're a seasoned developer, this discussion will illuminate how these systems work and why they're so important for maintaining efficiency and reliability. Let's start with the concept of active and passive views. In a distributed system, nodes connect and communicate with a set of peers, which we refer to as their active view. This becomes especially interesting when a new node, let's call it P1, tries to join the network. If P1's active view is empty, another node, say P3, needs to make room for P1 by replacing one of its existing peers. This process is crucial for bootstrapping, allowing new nodes to integrate smoothly into the cluster and become effective participants. However, there's a trade-off here. Cycling through connections can momentarily disrupt communication. Now, why do we focus on using only active view nodes for sending messages? Well, this strategy helps cut down the total number of messages flying around the system, which streamlines communication and boosts reliability. Passive views come into play as a recovery mechanism, helping to stabilize the network during changes in topology. A great example of a protocol that shines in this area is HyperView. It's known for its efficient view maintenance and strong focus on bootstrapping processes. Moving on, let's talk about hybrid gossip approaches, which are embodied in systems like HyperView and Plumtree. So what exactly is a hybrid gossip approach? It's a method that uses a small subset of peers for broadcasting messages, but can switch back to a larger network when things go wrong, like during failures or network partitions. One of the big perks of this approach is that it doesn't require a global view of all peers. This is particularly useful in large systems, where keeping track of every single member can be a real headache. By working with partial views, nodes can actively communicate with just a handful of neighboring nodes. This not only reduces message overhead, but also makes the network more resilient. It's a smart design choice that ensures the system can handle failures without major disruptions. Now let's explore the idea of replica divergence and the anti-entropy mechanisms that help address it. In distributed systems, it's common for the states of replicas to drift apart due to things like network partitions or node failures. To tackle this issue, systems often implement anti-entropy mechanisms to reconcile these discrepancies. These can take several forms. For example, when a target node is down, writes can be temporarily stored on neighboring nodes and then replayed once the target is back online. Another approach is read reconciliation, where nodes compare responses during read operations to spot missing records and synchronize the lagging replicas. Hierarchical hash trees are also used. By computing and exchanging these trees of hashes, nodes can identify which data ranges need repair. Additionally, maintaining compact write records helps nodes pinpoint missing updates for synchronization. These anti-entropy methods aim to optimize various parameters, such as scope reduction, recency, or completeness. For instance, read repairs focus on synchronizing only the data that's actively queried, while hinted handoff targets individual missing writes. Techniques like bitmap version vectors can track recent diverged events, enabling efficient synchronization when failures occur. And for a comprehensive comparison between datasets, hashing data and using Merkle trees can streamline the process of identifying discrepancies. Finally, let's highlight the importance of gossip protocols in this whole framework. They play a crucial role in reliably distributing information across large-scale systems. By employing a hybrid gossip approach, these protocols minimize the number of messages exchanged while still being resilient against network partitions. This reliability is particularly vital for systems that require robust failure detection and accurate membership information. In modern distributed systems, gossip protocols are frequently put to use. For instance, Hyperview is a key player in the high-performance, high-scalability distributed computing framework known as Partisan, while Plumtree is utilized in the React core for managing cluster-wide information. These real-world applications underscore the practical significance of gossip protocols. In conclusion, gossip protocols and anti-entropy mechanisms are essential elements of distributed systems, enabling efficient communication and data consistency across expansive networks. By grasping the dynamics of active and passive views, the advantages of hybrid gossip approaches, and the strategies for tackling replica divergence, we can truly appreciate the intricate design and functionality of these systems. As technology continues to evolve, the principles behind these protocols will remain foundational for building resilient and scalable distributed applications. Thanks for joining us today. We hope you found this discussion enlightening, and be sure to tune in for our next episode, where we'll explore more exciting topics in the realm of distributed computing.